welcome everyone. Thanks for joining us today. So this will be a workshop where you will be learning how you can ingest data from DynamoDB and perform real-time analytics with RisingWave. And this is like after the recent acquisition of Rockset, this is quite in demand topic, and we are happy to host this workshop and for everybody looking for alternatives, help you choose the right one. Today with me is my colleague who will walk you through and who will also share a demo with you, Kexiang Wang. Kexiang is a software developer at RisingWave Labs. Very nice to have you today, Kexiang. And Kexiang is working on stream engine and source development at RisingWave, and apart from that, has a broad interest in storage and other system areas. So before we move to the actual workshop, let's just remind ourselves of some like housekeeping items. So everybody, just heads up, you will be muted, but at any time you can ask a question either using Q&A tab or just writing something in the chat. The webinar, yes, will be recorded for everyone who asked. And if you have any issues with Zoom, feel free to, reach out to me or just type something in the chat and we'll try to fix that. Okay, that would be everything for the housekeeping items. Kexiang, the floor is yours. Again, nice to have you.
Okay. Thank you, Joanna. Good morning. If it's not morning, good afternoon, evening, everyone. Thanks for joining us today. I'm Kexiang Wang, a software engineer here in RisingWave Lab. I'm thrilled to share some exciting updates with you. So recently, after the acquisition of Rockset by OpenAI, we have heard a lot of feature requests about DynamoDB source in our open source community. So here, I'm just going to show you how what's the update on this side. What will we carry out the DynamoDB source in our system. So before starting, I will give you a quick introduction about RisingWave, especially who are new to RisingWave. RisingWave is an open source streaming database designed for making real-time data processing simple and efficient. Our goal is to help organizations process and analyze large volume of streaming data in real time, turning it into actionable insights. One thing that really sets RisingWave apart is ability to combine stream processing and the serving of the results in one single system. This integration means you can move from data ingestion to insights seamlessly without the need for separate tools or complex pipelines. RisingWave also stores the results of continuous computations along with the source for historical analysis. So not only do you get real-time analytics, but you also dive deeply into the historical data without needing another system for storage. We're guaranteeing fresh, consistent query results through high-level interfaces like tables, materialized views. This means your queries always reflect the latest updates. This give you accurate and timely insights. And we use SQL as our querying language, completed with the support for user-defined function, which allow you to implement customer logic and perform some complex transformations right within RisingWave using the SQL language. Another key feature is our elastic scaling of resource, which ensure you have the best price performance ratio. You can efficiently manage your resource, scaling up or down as needed without compromising on performance. All of this means RisingWave make it really easy to work with your streaming data. It's a powerful tool that help you get the most out of your data in real time. Here's a diagram show you how RisingWave interact with different kind of system. It can read from upstream data source like stream system like Kafka, Pulsar, or Redpanda, or the relational database CDC like Postgres, MySQL, and MongoDB, or the batch data from AWS3 or Hadoop. And then with the BI tools like Metabase, you can interact with RisingWave through SQL interface. And then if you want to get a result, you can sync the result of your computation into downstream system like Snowflake, S3, or all kinds of other system. Next, I will have a quick introduce of our another key players in this talk, which is DynamoDB. DynamoDB is a fully managed NoSQL database service provided by AWS in order to provide fast and predictable performance with seamless scalability. Their official slogan, as shown here, is serverless NoSQL fully managed database with single-digit millisecond performance at any scale. It's an ideal database for use cases that require high availability and low latency data access, such as real-time bidding, gaming leaderboards, or IoT applications. DynamoDB supports key value and document data models, making it versatile for a variety of workloads. So here I just present a simple diagram shows you how DynamoDB work. It will include basically two parts. One part is the primary keys. Usually it will include two parts. One is the partition key, which is used to partition your data into several splits. With this, they can achieve high scalability and high performance. Also, another part is the sort key. Within each split, in each partition, all the data will be ordered by the sort key. And they also have the value part. In DynamoDB, there's no any constraint or limitations on the value. It can be anything. For example, in this example, it may include like something like age, height, the workplace, your occupation or your gender, something like this. But there's no any constraint. It can be anything. Can be a list or JSON or just empty. So this is DynamoDB, and now let's talk about our integration ways for RisingWave to integrate with DynamoDB. Some of you may have already been using our DynamoDB sync connector, which allows you to write the process data from RisingWave to DynamoDB. And in this talk, we will introduce DynamoDB source, which instead allow you to read data from DynamoDB and process it in RisingWave. Sorry. Sorry. As DynamoDB provide limited analysis abilities, basically you can only do some simple analysis on DynamoDB itself. So it's a common usage that user want to sync data from DynamoDB to other system, other analyze system like Redshift, Elasticsearch, which allows you to process and analyze data with some more complex queries. So there are some like standard steps in order to do that. First, usually people will first fully export all of the data to AWS in DynamoDB into AWS3 as a snapshot, and then exactly after the timestamp when you trigger the S3 snapshot, you will start to stream all the changing events to your target system or target DB. And then you will connect your target DB or system to S3. It can be Redshift or RisingWave. In our system, of course, it's RisingWave. And then also the system also need to capture the changing event stream. So with this, your system, your DB, your RisingWave can keep up with all the changes in DynamoDB, including both the newly arrived items or the historic data. And the last step is based on the data in your database, you can do some analysis work, querying data, and make some prediction. And here is the architecture in our design. We use as the standard steps, we use AWS3 as a snapshot base. So first, DynamoDB will make a snapshot on S3, and then we use Kinesis as a middleware for transform the database the DynamoDB streams into our system. So actually, DynamoDB provide two ways to do that. One is Kinesis data stream. Another is DynamoDB stream. In our system, we have better integration with Kinesis. So in this example, in this demo, we will use AWS3 and Kinesis as our middleware to do all of this. And in RisingWave, we will do two things. First, we will create a table for both AWS3 and AWS Kinesis. And this two table will just ingest the data from the upstream, and then we use sync. Sync is one core important component in our system, in our SQL language. It will sync all the data in the Kinesis table into our base S3 table. With this, finally, the base table will contain all the data and all the changes. Next, I will use a demo in gaming data I will use a demo in gaming data analyze scenarios to show you how it works. In this demo, I will walk you through the setup and the configuration of DynamoDB source, and also the configuration in RisingWave's DynamoDB connector, and show you how easy it is to start ingesting data from DynamoDB to RisingWave. We will also explore some practical use case and highlight how this new feature can enhance your data processing workflows. And by the end, you will see how the DynamoDB source connectors can help you unlock the full potential of your data in both DynamoDB and RisingWave. And I hope this demo can provide you some insightful and inspiring cases for you to analyze your data. The scenario will be a famous game, Fortnite gaming data analysis. This Fortnite game is a very famous battle royale game. Basically, you will be sent into somewhere, and then you fight with each other. The last one survive will be the winner. And the data set is some gaming statistics in matches of 400 players. So basically, we will assume that there will be 400 players, and they will constantly playing matches, and each match will produce some data, and we will do some analysis on this data. Basically, how do they perform? Who is the best player? The query we will run is a summary of top players based on their average survival time within 10 minutes window in the Fortnite game. And there are two prerequisites for this demo. One is one RisingWave cluster to do all of the process work, and another one is the DynamoDB to accept the original data. And before we move into the practical part of our session, I would like to give you a brief introduction to the platform we will be used today, which is RisingWave Cloud. RisingWave Cloud is our managed service offering designed to make deploying, managing, and scaling your streaming data workflow effortless. With RisingWave Cloud, you can get a user-friendly web interface that allows you to quickly set up data source, define streaming jobs, and monitor system performance all of this without any worrying about the underlying infrastructure. This means you can focus on analyzing and processing your data while we handle the heavy lifting behind the scenes. Additionally, RisingWave Cloud takes care of the routine maintenance tasks like updates, backups, ensuring that your data is always secure and your system is highly available. With robust security measure in place, you can be confident that your data is always being protected and compliant with industrial standards. Okay, thank you for being here. Let's dive into the demo. So I will start with the workload. So like I said, we will use the Fortnite game data as the data source. So I actually write a script to generate data. So in order to simulate the no more scenarios in production, we first generate some data. Also, one thing I need to introduce is before our webinar, I have already created a DynamoDB table in our DynamoDB dashboard. You can see it is called game analysis. And currently it's totally empty. There's even no one item in this table. And then in order to get some data into the DynamoDB, I will first produce, like there are already some data. I will insert some data into the DynamoDB as the batch data. So let's run this query. Okay, we can take a look at the data. So the data will be start with match ID and player games. The match ID is actually also the partition key, and the sort key will be the player name. So in our item, these two are included, and there are also some fields like player rank, like revivals, like assists. These are key metrics of a player. And in this script, we just random generate some files data to simulate there's some matches going on. So after we generate data, after we send data in batch to DynamoDB, we can see it here. You can see in total there are already 50 items in DynamoDB, and then imagine that we are now going to do some analysis based on the system, and we already have some data in this DynamoDB table. What we need to do is first we need to explore all the data as a snapshot to S3. So here I just click on this, and in order to use this feature provided by AWS, you need to turn on PITR. Basically, this is a technique provided by Amazon to allow you to do some backup for the data in your DynamoDB table. And I have already create a bucket in S3. Let me show you. Okay, the name would be the bucket name would be WKX DynamoDB, and we will send the data under this directory. So only thing you need to do is type the directory in this blank, and then specify that use a DynamoDB JSON. Then click export. It may take like 1 or 2 minutes to get it ready. So you can see here. Okay, let's wait a bit for this exporting. And I have so in previous experiment, I have downloaded some data for this experiment. So it will be like this. So this is the data generated by our grid. We can format it a bit. So DynamoDB will dump data like this. It will the value and the primary key will be embedded into one JSON will be embedded into one JSON base. The label will be item, and for each column, it will have a column name, and under the column name, there's one object with a label either B, N, or S, or something else. It will tell you, okay, it is a number or a string. N here means number, S means string. And the last part is the real data, like what's your match ID, what's your player name. So that's how DynamoDB's S3 table looks like, S3 data looks like. Let's see whether it has been still exporting. It usually takes some time, so we need to wait. Okay, we can say it's already something here. It will under the directory you specified before. It will create a directory called AWS DynamoDB and create a directory with the name of the timestamp. And under this, there will be some data. Sometimes we just need to wait. It's sometimes very quick, like 20 minutes, 20 seconds is enough. But this time it seems to be a little bit slow. We can do this again in case there's something wrong with AWS 3.
Xiang, I was wondering in the meantime, while we wait for things to move forward, if you can answer the question in the chat.
Okay. Yeah, thanks for this. Are there any best practice for or recommendation for resource management to ensure continuous? Do you mean for DynamoDB or for RisingWave? For RisingWave, it depends on your workload. So it depends on not only the throughput you want to achieve, it also depends on your SQL. There will be some queries very resource consuming, and if you just do something like transformation, something like aggregation, then the workload is very light. In the scenarios, usually, I think you can start with our developer tier, and then increase. If not sufficient, then you can increase the cluster scale step by step. And if you already have a large amount of data to be processed, you can contact our sales, and we will do some evaluation for you. And for if you are asking for DynamoDB, then you should contact AWS DynamoDB team. Oh, why it's so slow today? Let's try again. I don't know why. Or maybe use another. Don't know why there is. Maybe we can first continue the next steps. I'm waiting for this. One thing is to enable the exports to S3. It will create snapshot based on your request. So like I said, like you see, okay, finally we get something done. Okay, this is the first snapshot I made. So you can see under the AWS3 directory, there are two different directory. One is for the first one is for the second one. The name with with smaller number will be the first one. So in the future demo we will use this one. So okay. Then the first step is done. We have already created a S3 snapshot. The next step is after we create a snapshot, we need to also create a stream to capture the changing events. So here we just simply choose one Kinesis stream in your system. So in our webinar, I have already created one Kinesis stream in advance, and in your production, you may need to create one when you want to turn on the Kinesis stream, and we just simply turn on, and then after like 1 minute, it will be on. And now in the stream, we can see. So at this time, as we just created a stream, there's no data in the stream. And now I'm going to start the generator to put data into the Kinesis stream. So here you can see what I did is just So what I did is just start to generate data with a frequency of 20 row per second and put data into. So here back to the DynamoDB table, we can see the number of the rows is increasing. So previously it was 98, now it's 135. So it means the data is already being changing. And we can see in Kinesis, with the data viewer, we can see there's some like a change event shows there's new events in DynamoDB. We can open one line. Oh, sorry. So you may notice the format is kind of different from the S3 format. There are besides the image, the rows, there are also some other information, including like event name, user identity, or record format. This are some meta information for the string. In our system, in RisingWave, we only care about the event name, basically what kind of operation it is working on, and what's the keys, what's the new data, the old data. And now we have one DynamoDB table fully prepared, and in RisingWave, we will start to consume data from this. So the first thing we need to do is connect to read the data from the S3 snapshot, right? So I will write a table like this. So the table is based on the S3 connector because the data is on S3. And another thing we do is we write a DynamoDB S3 parser for this data format. Basically, as I just showed, there's something like item, which is different from normal JSON. And also, in order to use this in order to use this format, you need to specify some information. First is the primary keys, including the partition key and the source key. And besides that, you also need to tell us what's the data name through this JSON property, single JSON B column. Like I mentioned, like in DynamoDB, there's no constraint on the values. It can be any format. So by design, we decided to just embed all the information into one JSON-B, and you can use this property to specify what's the name of this JSON-B column. So with this, we can try run this. Okay, sorry, this is not going to. I just use the old table, so I need to first drop it. So one thing we need to make sure is the paste here is correct. Like I just did what I did wrong is because I use some old data to generate. So okay, with this match pattern, we specify which directory should read for this S3 data for S3 data table. So here we can see we already have started to ingest data from the S3 table. We can count the number of the data. So like in our experiment, we just generate 50 rows as the batch data. So from S3 we can really only read 50 rows. And the next step is create the kinesis data table. And in this example, I've already you can say the table is create successful. It works similar. Also, you need to specify the primary key and the name of this JSON-B column, and then we can try read from the table. So you can say currently the number of the rows is 620, and if we run it again, it will increasing because there are data continuously getting to the system, getting to DynamoDB, and we just keep up with the data from DynamoDB. And after that, we need to unify the data from different sources together. In order to do that, we can create a sink from this game kinesis into a game, the S3 table. With this, all the data, all the changes getting to game kinesis will be also dumped into the S3 table. We can check it by running. Oh, sorry, I haven't run this. So now the game kinesis is connected to the game table, and we can check the number of the game table. You can see the number is currently about 1,116. And if we run it again, it will increase. So it means it's reading data in a real-time way. And as I said, by default, we read all the data as a JSON-B. But in production, you must want to read the real columns. So in order to get the columns, you need to do is extract the data from the JSON-B. So here's an example. So you can see with this materialized view, it will read from the game table and then extract column like match ID, player name, and time survival and time step from the row. Here the NS means whether it's a number or a string, and for some string it's time steps format. So what you need to do is convert it into a time step. You can try run it. Okay, it's finished, and we can take a look at this table, at this materialized view. So you can see after creating this materialized view, we already have this table. We already have this materialized view with different types of columns that extracted from the JSONV column. For example, the timestamp TS here is timestamp type. The time survival is integer type. Player name is a voucher, which is all of this are database type instead of JSONV type. And now we have all the data prepared in our system. We will do some real analysis on this data. So like I said, we will do analysis for the top players based on their average survival time within a 10-minute window in this game. So the query I have written is here. So it basically has three phases. In the first phase, we will divide all the data into a 10-minute window. So basically, all the data get into RisingWave will be grouped by 10 minutes interval. And this data will have a window start and window end to specify which interval it is in, which interval window it is in. And in the next phase, we will just rank based on the average time survived. And the last part will be the data extraction part, where we just fill out the rows we are interested in. And with this, the materialized view is created, and if we want to check the numbers, we can simply select from this materialized view in order to easily recognize the difference. We will order by the window start. So always the newest table, the newest event will be shown here. So you can see with different window start. So every window start have a interval of 10 minutes. The window start will be like 2 p.m. and the end of window will be to 10 p.m. And so you can say the number is actually the number of data is actually changing. If we run it again, the data will be different because there are consistently new data coming in. So the data will be different once there's some update. So from this query, we can know who is the top player every 10 minutes in this game. So that's basically everything of this demo. We use let's just have a quick summary. We use Fortnite game data to show how we use RisingWave to connect to DynamoDB, to sync with DynamoDB and do some analysis work on the DynamoDB data. And currently, we still require users to create two tables and merge them together through a creating sync cycle. And what we are now trying to do is unify them together using one single source to read both from S3 and Kinesis. And for the current design, it is expected to be released in this month, and for at the end of this month, and for the future plan, it may be released in the next month. And I think that's all for everything for today. If you're interested in this feature or interested in RisingWave, just contact us through any possible way like Slack or GitHub, or email our salespeople. And now, if you have any question, just feel free to ask. Use the Q&A function. Oh, I saw one.
There are some
I have a
questions.
question.
If you can
Yeah,
just
I have a
read
question.
those. Yes, if you can just read those for everyone to see. Those that are.
Okay. I have a question regarding DynamoDB streaming solution. DynamoDB offers two well-established options to stream data from it, DynamoDB Streams and Amazon Kinesis data stream. I'm curious about the pros and cons of each solution, particularly in the context of data ingestion into RisingWave. Can you please provide a detailed comparison of these two streaming options, including aspects as latency, scalability, ease of integration, cost, and any other relevant factors that might impact the efficiency and performance of data ingestion into RisingWave? Additionally, are there any specific use case where one might be a more advantages over the other? Thank you. Oh, really long question. So maybe let's use slides to illustrate this. Another question. Let's first answer the first question.
Yes, please.
So DynamoDB provide two ways. One is Kinesis data stream. And another is DynamoDB stream. So for advantages, each of them they have some advantage. Like for example, for Kinesis, Kinesis is a standard component in AWS ecosystem. So many people, many users they use Kinesis. So like us, we have supported Kinesis for long. So for the user who are familiar with Kinesis, it's pretty easy to use, and you don't need to add any actual setup, any actual client library to ingest data from other system. You just reuse your Kinesis client to access data. So that's the advantage. It has a much more plentiful ecosystem in AWS. And for DynamoDB streams, it's only for DynamoDB. So in order to use this, you may need to, for us, for RisingWave, we may need to write a new connector, a new data connector, which is much more effort. And I believe most of the vendor who provide this connector abilities, they would prefer to use Kinesis. But there are some advantage for this DynamoDB streams. So DynamoDB streams do not require an actual component like Kinesis to do this. They can directly send the stream, the event to your target system. Maybe take this diagram as an example. So if we're using DynamoDB streams, there's no Kinesis. The change stream will directly get into RisingWave. So from considering this, with DynamoDB stream, you do not need to pay for the Kinesis setup. But relatively, the cost is minor considering with the DynamoDB itself and they analyze or the processing tools. They cost and for scalability, I'm not quite familiar with this part of DynamoDB streams, but I know well about Kinesis. Kinesis provide good scalability, and in order to increase scalability, you can actually partition. So Kinesis provides some ability that allow you to partition data into several split, which can provide better scalability and availability. If you want to increase scalability, you can just configure with Kinesis to increase the number of partition, which can help you increase the throughput and the scalability of this kind of things. And the second question is, how does RisingWave handle scalability when dealing with large volume of data from DynamoDB? Basically, within the last question, I've answered this. So as we use Kinesis, so the scalability part is mainly the bottleneck is mainly like to be Kinesis, because in RisingWave we can either scale up if you have higher throughput to achieve. For example, currently it's like 100 per second. You want to get it like 100. It just you just need to increase the amount of resource, and we can easily handle larger throughput. It's almost linearly. And for Kinesis, it allows you to set up something like number of shards, number of partition. With this, they can have more thread in parallel to read data from DynamoDB, and also you can read in parallel for RisingWave. You can read in parallel from Kinesis. So in this way, you can achieve high scalability. So even you have large amount of data, just increase the number of the partition, then it can be solved with both in Kinesis and in RisingWave. And this third question, how can we optimize our setup to maintain low latency under high load conditions? Oh, good question. It's for RisingWave, right? For RisingWave, we provide in this dashboard, we can see we provide some metrics for your system. My cluster is a bit tricky, so sometimes I do not show the numbers. So you can see we have the metrics for the current usage, like CPU or memory usage. You can just keep an eye on your CPU usage. If it's not high, for example, currently CPU usage only like 7%. But if the CPU usage is already very high, it means the resource is kind of insufficient. So in order to keep low latency, the best way is scale up, make sure that there's enough CPU and memory resource. With this, there will be no pressure, making sure that your system is in a healthy state, then the latency can be achieved. Even with high load, just add more resource. And the last question is for current Rockset customers looking to transition to RisingWave. What are the major difference and potential challenges we might face? A good question. So Rockset is a index-based system, so it's a little bit different from RisingWave. RisingWave is the main idea is materialized view. So we consider things in a streaming way instead of index way. So for the queries previously written in index organized, you may need to convert into materialized view based. So for example, previously, if you want to do some analyze, for example, just as this example, you want to know what's the top players, you create an index, but in RisingWave, you need to create a materialized view. For the DynamoDB source part, the grammar and the semantics is a little bit different. So you may need to get some time to get familiar with this part. So that's the major difference and potential challenge. But in general, I think both of these two products provide good scalability and availability. So you won't face too much challenge, something like you need to adapt to the new system. Any other question?
I think that would be all. Many thanks everyone for the questions. If there is something else Kishan can answer, last call. If not, thank you everyone for attending. I've noticed that some people were like a little bit late, so have missed the first part. The recording will be sent to you. And thank you once again for attending the workshop. See you next week. Bye.
Bye.